Okay, we are going to solve a system now by using an inverse matrix. And the first thing that we need to do is we need to write it in AX equal B form. Okay, so a matrix equation, we need to write it like this. All right, so we first write out the coefficient matrix 4, -1, -9, and then -3, 9, and 3, and -9, -6, and 1. Okay, so let's just double check. 4, -1, -9, -3, 9, 3, -9, -6, and +1. We then write our variable matrix x, y, z. Okay, write our variable matrix. And then our solution matrix is -55, 81, and -77. Okay, so let's think about this real quick. Well, what would we do here to solve for x if this was just a regular elementary equation? Well, we would divide by a, right? We would divide by a, and then we'd get x, and it would be b over a, right? Well, in this case, that's actually not correct. So if you have the matrix AX equal B, the matrix equation, this doesn't work, but the same concept applies. In this case, division of matrices doesn't exist, but the inverse of matrices does exist. And that's the idea that we're going to use. So to say that x equals A inverse B is the approach that we will take to solve the matrix equation. So the product of A inverse and B will actually give us our x, our y, and our z respectively. So that's actually kind of cool. All right, so what we're going to do is we are going to write out this matrix A and write out this matrix B, and we're going to find A inverse B. All right, now in order to do that, I'm going to make it actually very simple for you. I'm just going to show you how to do that very quickly on the calculator. Okay, if your teacher requires you to do a 3 by 3 inverse, maybe it's a bit of an overkill, but go ahead and figure out how to do it, and then you know, work out the process. I think it's overkill, but let's go ahead and take a look. So we're just using our standard graphing calculator here. Let's go ahead and go into the second matrix menu. I'm going to go over here to edit, and I'm going to edit matrix number 1. It is a 3 by 3 matrix, and I'm going to key in the numbers just as I see them there on the paper. Okay, oops, let's go back. I inadvertently clicked something here. Okay, so 4, -1, -9, -3, 9, and 3, and then we have -9, -6, and 1. Okay, just double checking that. 4, -1, -9, -3, 9, and 3, -9, -6, and 1. Okay, cool. Now I'm going to quit that. I'm going to go back to my matrix, and I'm going to edit number 2, which is B, and this is a 3-row by 1-column matrix, 3 by 1, and it looks like that. And I'm going to key in my solutions, -55, 81, and -77. There we go. So I've got my two matrices A and B, and I'm going to quit now. And I'm going to say, okay, I need to write this out. So again, I'm going to hit second matrix. I'm going to click number 1 to call up matrix A. And if you see here underneath the word matrix is the inverse button, perfect. A inverse, now I need to call up second matrix, and then I'm going to click number 2 for B. A inverse B, just like I have here on my paper. And that actually makes this really nice. So sorry about that. I just realized that the paper was crooked. But A inverse B, and I'm going to hit enter. And guess what? There is my solution. So my A inverse B is the matrix 4, 8, 7. So what is my ordered triple in this case? Well, the intersection here is 4, 8, 7 for X, Y, and Z. And so this is my solution for this system using inverse matrices. So the calculator actually comes in very handy. Okay, so good luck with these types of equations.